Welcome to my channel, everybody. And this is the geometric progression. And here is the 4, 1, 2, 3, 4, 5 question is here. And want to solve this question, the very important question for the different type of competitive exam also. Okay. And see, the first one we want to solve the first 21. Okay. And this problem, most of the students are facing some problem, so that's why we attend this question first. Okay, now see 21. Okay, this is 21 number question and of the book of Ashende, and this is the most important question. If m plus 1 term and n plus 1 term and r plus 1 term of a AP series are in GP, and so that, and also given that the 1 by m, 1 by n and 1 by r are in AP, and then find the ratio of the first term of the AP to its common difference in the term of n. Okay, again I repeat, of a sum AP, there are the m plus 1 term, n plus 1 term and r plus 1 term, they are in GP. These three terms are in GP, and also 1 by m, 1 by n, 1 by r are in AP. And now find the ratio of that AP in which find the ratio of the first term with the common difference. Find the ratio of the first term with the common ratio. In term of n, we have to find the value of n here. So let us assume A be the first term and D be the common difference. Okay, A be the first term and D be the common difference. Let A be the first term and D be the common difference. Then T suffix, that is m plus 1, is equal to A plus m plus minus 1 into D, that is A plus md, and T suffix, that is n plus 1 is equal to A plus n plus minus 1 into D. This is equal to A plus nd, and T suffix r plus 1, that is equal to A plus r plus 1 minus 1 into D. These three terms are in GP. These three terms are in GP. Therefore, we can write here A plus MD by A plus MD, and that is equal to A plus RD divided by A plus MD. Okay, and doing some technique here. See how can solve easily. This is doing minus 1 and also this is here minus 1, and this implies that if we take a LCM, then we get there n minus n with multiplier d. You also cancel on the both side, but for students' query, so I write this. This is there r minus n into d. If we take a LCM, then a and cancel and taken d as the common, then we get here in r minus n here and n minus n here. Okay, and see a plus nd. See these two d are cancelled, so these two d are cancelled, and right here again a plus nd. This d nd are transfer here, and these are a plus md. And now see, what the relation here is r minus n by n minus m here. Okay, so see carefully. So again, I'm doing minus 1. So a plus nd, a plus md doing minus 1 and equal to r minus n, n minus m minus 1. So see, this is at a plus md and taken common d here. This is n minus m. This is n minus m, r minus 2n plus m here. And again write here like a plus md divided by d as this, and write here n minus m as a whole square by r minus 2n plus m, implies thus this by this as a by d. This is your queries, and this is plus m, this by this d, then we get here m, and that is equal to n minus m whole square and divided by r minus 2n plus m here. And now this is your queries a by d here, and m are transferred to the right hand side and take a LCM. Then n minus m whole square by r minus 2n plus m minus m here. Okay, then take a LCM here. Okay, and now expand this n square plus m square minus twice mn, multiply this, there is mr plus 2mn minus m square. So see, these and these are cancelled. So we get here just n square minus mr, and here is r minus 2n plus m. Okay, and now this expression would be in terms of n only. So here is the various variable are related with m, r, n. Okay, now how can we eliminate the variable r, m, r also? So another case is given that these three variables are in AP. Now 1 by m, 1 by n, 1 by r are in AP. So 1 by, this is 2 by n, that is equal to 1 by r plus 1 by n. Actually, in that question, we don't find n as our requirement is here is in term of n. So either if you eliminate, you can eliminate r or m. So now find here m. Okay, now find here r. Okay, so that is your choice. This is my choice. Here is I want to eliminate the variable here is r. This is by 2 by n, and this is here 1 by m. And take a LCM. This is mn, and this is 2m minus n. Okay. So therefore r is equal to mn by 2 minus n. So substitute the value of r this place and this place. Then what we get? See here, a is to d, and that is equal to, this is n square, m into the value of r is there is mn by 2m minus n, and also on the numerator there is also r here, so put the value of r is mn by 2m minus n here, and also 2n plus m. Okay, and take a LCM. Then we get here 2m n square minus n cube minus m square n, and now also mn here is multiplied by 2m, this is 4mn. Okay, and now plus this is 2m square, and now we then this is minus minus plus 2n square, and this is plus minus minus mn. Okay, and take a common here n, and we are left here mn minus n square minus m square. Okay, and now see here mn or mn are cancelled, so we take here minus 2 only, then we get here 2mn minus m square and minus n square. So see, these two are cancelled, so this variable is here minus n by 2 only. So a by d are in the form of n by 2 here minus. So this is the question is proved, and the very interesting question, see carefully, very interesting. Okay students, take care. Okay, so 21 is complete here. So again student, see the solution. Now follow the marks 5 question number 15. Okay, you have given and the three numbers that are in AP. So 15 here, A comma B comma C are in AP. So 2B equal to A plus C here. Okay, and also given that and A comma B minus A comma C minus A are in GP. Then B minus A by A, C minus A by B minus A. Okay, and see, now find the ratio A is to B is to C. Then that's why we have to find here B by A, and this is there only one here. Okay, now find C only is the one variable, so that's why you find C. So you can write here C is equal to twice B minus A here. So write here twice B minus A, and that is B minus A also. So take a common 2. Then after B minus A, and there is a B minus A also. So this is cancelled, this is equal to 2. So B by A minus 1, that is equal to 2 plus 1 is 3 here. So we can write implies that B equal to 3A. So now again this case we have to take in, and either you have to also take in like as C. So C is equal to twice B minus A here. So substitute here as A in place of B. So this is 3A minus A, and that is 5A. So now find A is to B is to C here. So in place of A we can unchange here, but B here is 3A and C here is a 5A. So then A are simplified, then we get here A is to 3 is to 5, 1 is to 3 is to 5. Okay, see, this is your queries, so which is good here. So now 17. Now we have to proceed the question number 17. Very interesting question. And see, so some of the n terms. So now notation is there as n. After that, this is 1 by 2, 3 by 2 square, 5 by 2 cube. So first this is the 2n minus 1. Actually you see that the order 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power n. So this is the nth term. Okay, and see 1, 3, 5, this is the odd number. In term of odd number notation, that is the last term be 2n minus 1. So previous term would be a 2n minus 3 r also. Okay, and this is the 2 to the power n minus 1. And why we can write here in the previous term, after the sum, next time we have to write sum here series. So you see what happened here. So if we omit in my brain to all of you 1, 3, 5, this is an odd number. The remaining all are like 1 by 2, 1 by 2 square, 1 by 2 cube. These are in GP pattern. So the ratio we have 1 by 2. So that number, if you multiply this series, then what we get here? See here 1 by 2 into a n. So after that, this is 1 by 2 square. So this, see here, this is a 1 by 2 square. So right here 1 by 2 square. So then after we subtract, then we get a perfect subtraction. Then after that, if we multiply by 1 by 2 here, we get there 3 by 2 cube. See carefully, okay. After that, if we multiply this term, then we get a 2n minus 3 by 2 to the power n here. If we multiply by 1 by 2, then we get here 2n minus 1 by 2 to the power n plus 1 here, okay? Then we subtract. So what happens, see, the solution, this minus this, we get here s n minus, and that is half sn, okay? So after that, this is here half. If we 3 by 2 square and 1 by 2 square, we get here 2 by 2 square actually. And then after, this is 2 by 3, 5 minus 3, this is 2, and this is the LCM here is 2 cube. And all the series we get here 2 by 2 to the power 4, all the series within the bracket from these to these, except these and half. In between the series we get a GP series. Okay. So then also this is 2 by 2 to the power n here. After that, this is the free from the other term. So this is does not depend on the series here. So see, this is Sn by 2. Okay, and take a common 2 here. Then after this is 1 by 2 square, 1 by 2 cube. And also we can write like that, 1 by 2, 1 by 2 square, 1 by 2 cube, like that. This is 2 to the power n minus 1, okay? And 2 to the power n 2n minus 1 by 2 to the power n plus 1. So see, this is the GP series, and whose first term we have half, and this is here 1 minus, the ratio we have half also. And the number of term from 1 to n minus 1. So number of term here n minus 1 here, okay? And this is here 1 minus half also. And 2n minus 1 by 2 to the power n plus 1. Actually multiply by 2 and then 2 are cancelled. Okay, Sn by 2 here. And then multiply by 2. So this is Sn. Then multiply by 2, we get here 1. These two are, these half and half are cancelled. So multiply by 2, so we get here 2 into 2 times of that. 1 by 2 to the power n, and this is to the power minus 1 by 2, so multiply by 2 here, okay? If we multiply by 2, then 2 are cancelled, so 2n minus 1 by 2 to the power n. Actually we want to add this to figure, okay? So then we get a simplified form. So this is here 2 to the power 4, 2 to the power 4, and 2 to the power minus 1, 2 to the power n, and 2n minus 1 by 2 to the power n here. So this is here 3. So take a common, and LCM we have 2 to the power n. So this is here 2n, this is also minus 4, this is also minus 4, this is 5 here. Okay, and this is your answer. Okay, see the solution carefully. After that we have to proceed the question, next question, that is 19. See the solution, very interesting question this, okay? And we have to solve the 19 here. So one geometric mean G and the two arithmetic mean P and Q are inserted between the two given number. Let the number let the two numbers are x and y. Okay. So x comma g comma y are in GP. So g by x and y by g, and that is equal to g square equal to xy. This is one. After that, x comma p comma q comma y are in AP. Insert between the two PQR arithmetic means, so are in AP. So we can take like that p minus x, q minus p, and y minus q. If we take these two, then what we get? So x is equal to 2p minus q here. Okay. After that, if we get take these two, then what do we get? Then y equal to this is 2q minus p here. So this is 2 and this is 3. So from 1, 2 and 3, that is g square equal to xy, and the value of x is, that is 2p minus q, and also y is 2q minus p. So this is your query, which is proved. Okay, see the calculation carefully. Okay, So now, next question, that is 24. And this is also a very interesting question. A1, A2, A3 dot N are in GP. So you can write here like A2 by A1, A3 by A2, A4 by A3, and the last term here is AN. Okay, AN by, sorry, extra term we are repeat. Okay, and this is AN by A suffix N minus 1, and that is equal to ratio, no, this is EV1 and then so that actually I'm not wrongly written here. The ratio are given that this is R. So sorry. No, I mean does not mention here. Or say R with the ratio and R with the ratio here. Okay. So mention to be needed here in question. There was a not represent the R. What is the representation of R here? R actually the ratio. Okay. So now A2. We can write here R into A1 and A3. This is R into A2 and A2 can be represented by that. So R square into A1. Okay. So same as A4. So that is RQ into A1 like that. And same as we can write A suffix N minus 1, that is equal to R to the power. If 4, then we get 3. If 2, 3, then we get square. So if n minus 1, then we get here n minus 2 into A1. And also An, that is R to the power n minus 1 into A1. So similarly, now we write the here the left hand side here A1 square minus A2 square. Okay. Now A2 square minus A3 square. Okay, dot dot. This is here An suffix n minus 1 square minus An square. Okay, now A1 square. Okay, and A2 square. A2 square means here R square A1 square. Okay, A2 square, that is R square A1 square. A3 square. A3 means this is R to the power 4 and A1 square. Again I repeat as next term A3 square. A3 square means here R to the power 4 and A1 square and minus A4 square. So that is R to the power 6 into A1 square. Sorry. This is a square. So you can write square, that is R to the power 2n minus 2 into A1 square. Okay, minus R to the power, this is here 2n, this is here 4 actually. Okay, and take a common A1 square first. Then we get here 1 minus R square. Okay, take a common R square. A1's common are common taken from each of the term here. And in the second term we can take a common R square. Then we get here 1 minus R square here. And R to the power 4, we get here 1 minus R square also. Then R to the power, that is 2n minus 4 here. So then we get here 1 minus R to the power 2 actually. Okay. So see 1 by A1 square, and also these factors are taken common. That is 1 minus R square. So after that, this is here 1 and R square and R to the power 4. And this is 1 by R to the power n minus 2, and this is a square actually. Okay. So see 1 by A1 square and 1 minus R square. Okay, this is here r to the power 1, 2, this is r to the power this by this r square, this by this 1 by r square also. So 2, 1, 2. Okay. N minus 2. Okay. Now this is the sum. First term is this. So 1 minus this by this as a 1 by r square. So r to the power 2. What the number of term here is n minus 1, including this. Okay, n minus 1 by 1 by r square. Okay. So see, and if we take our LCM, then we get here r square by a1 square by 1 minus r square. Okay, and after that, this is a square also, r square minus 1, but here 1 minus r square, so taken from minus, so then we get there minus also. So now right here, this is minus 1, so right here, and this is minus 1 here. Okay, so r square by this whole square, 1 by r to the power 2 whole to the power n minus 1 and minus 1, and multiply by r square by 1 minus r square whole square, and multiply by this a1 square on that. So this is here a1 square and r to the power 2n minus 2. Okay, minus a1 square. Okay, r square by 1 minus r square whole square, and see, this is the, if we square this, then we get is this. Okay, a suffix n whole square, then a1 square and r to the power 2n minus 2. Okay, see, so this is your an square minus 1 by a1 square, and this is your proof. Okay, see the calculation carefully. Okay, and today the last question is 17. So see, the 17 part 3, 17 part 3. Okay, and these all the problem are taken from the book of Yashindra. Okay, students, see. Okay, and now we write here 10 plus 100 plus 1000 and 10,000 dot to n. After that, we have left 2, 5, 8, 11 to n. Okay, see, this is a GP series whose sum is actually first term is 10. Ratio B had 10, so 10 to the power n minus 1 by 10 minus 1. See the calculation here. And this is a AP series whose sum is up to n. Here is n by 2. N by 2. We can write here 2a, and this is here n minus 1, and d here is 3. And this is 10 by 9 and 10 to the power n minus 1. And this is here n by 2. We can write here 3n and 4, and this is plus 1. Okay. Okay. Bye everybody. Very interesting class today. See the solution carefully and see the video each and every viewers. Okay. Bye everybody.